Assalamu alaikum. Welcome to the 6th lecture of Software Requirements Engineering. In the 5th lecture, we talked about software processes and process models. We looked at the coarse-grained activity model in some detail from the requirements engineering perspective, and we looked at two different contexts in which the requirements engineering process has been described. Starting today, we will talk more about software requirements engineering process and different activities within this process. So to recap, our discussions so far, we know what requirements are, we know their types, we know some of the problems that are associated naturally with the requirements because they are described in the natural languages, either English or Urdu or any other language. And then we looked at the processes of different kinds of processes and how they depict the requirements engineering process. This slide that you can see on screen gives you a primitive definition of the requirements engineering process. It says the processes involved in developing system requirements. We will take this definition and then we will build details into it so that when we apply different processes, different steps and different procedures, we will end up with an agreed upon set of requirements which can then be used by the system designers to design and develop a software product. The next slide that you are seeing on your screen is an overview of the inputs and outputs of the requirements engineering process. As you can see that there are at least 5 different types of inputs coming in to the requirements engineering process, and there are up to 3 outputs from this process. The first input is the existing systems information. Second is the stakeholder needs. Third is the organizational standards. Fourth are the regulations. Fifth are the domain information. And the outputs are agreed requirements, system specification, and system models. We will talk about each one of these in some detail while you are looking at this slide, and then we will take each one of them and have some more discussion so that you can understand all aspects of each one of these inputs or outputs. The first thing that we had seen here is the existing systems information. This is again a very large set of information which tells us about how the current manual system is operating, and it also tells us about possibly some existing computerized systems, or it also tells us about existing manual systems which are not the subject of automation for any project. So the first will tell us the current scenario, the current situation that exists, so to speak, on the ground for a client company, and that is a very, very useful set or collection of information from the perspective of development of the new system. The second is the stakeholder needs. As we have discussed in the first 3-4 lectures about the requirements and the needs of the stakeholders, the stakeholders' needs are the primary source of information for the new product. Then we know that there are many different types of stakeholders, and each of them has a separate set of needs and requirements. So all of these would basically be lumped together here, and then they become an input to the requirements engineering process. Third, organization standards, and we'll talk more about them when we get to them in this separate discussion. Then we have regulations which may be imposed by the customer, which may be imposed by the local governments, which may be imposed by the national governments, or which may also be imposed by professional associations and standards bodies. And lastly, we have domain information, which plays a very important and pivotal role in the development of the requirements as well as development of any software product. Remember, domain information is a very important aspect of developing any software product, and sometimes it is not given due share or due importance, which can result in dissatisfaction of the customer. So let's move on to discuss each of the inputs. The first thing that we have talked about was the existing system information. Information about the functionality of the system that you are going to replace. As said, that the manual system that will be replaced by the new automated system will have to be studied very carefully. Now, this involves studying of the processes involved. This involves studying of how the inputs are generated in the existing system. It also involves how the outputs are produced. It involves different kinds of stakeholders, the users who are actually implementing that process, all included in the existing system information. The example of this would be when the government switched from old ID cards to computerized national ID cards. The existing system was obviously had to be studied. However, that computerized ID cards were issued by an entirely new organization, and the old government departments which were issuing non-computerized ID cards were not really the stakeholders in the new system. So they would then be considered as part of the existing system information and will not be the stakeholders. And I think the same applies when we switched from old manual passports to machine readable passports, whereby a new office was set up entirely for this process, and the old agencies were utilized in other ways. So it is interesting that the users of the existing system may or may not be part of the stakeholders, but they are part of the existing system information because they apply the process and utilize the manual process to execute whatever is being done. It can be payroll, it could be generation of ID cards, or it can be anything else. So, and also the interaction of the new automated system with other existing processes is also part of the existing system information. There may be existing automated processes already being used, or there may be manual processes which are not subject of this automation, but which have interaction with this new computerized system. And it is very important to not only study but also develop an interaction which can produce, which can increase the productivity of both the processes. So the existing information systems or existing system information would include a lot of information, and it is the responsibility of the requirements engineers to understand the relationships that exist between different processes within an organization. Let's consider the stakeholder needs. The stakeholders describe their needs and their wants as inputs to the requirements engineering process, and we had a good discussion about different kinds of requirements that come from the stakeholders, the possibility of generating inconsistent requirements or possibility of generating inconsistent needs because they're coming from different stakeholders. Different stakeholders may be having differences, due to political reasons within the company, or some stakeholders may have a very limited view of the software product that is being developed, while some other stakeholders may have a broader view and they may want to look at from a business perspective, and they want to use it as a competitive tool for years to come. So it then becomes the responsibility of the requirements engineers, obviously working with these stakeholders, to determine the exact needs for the software product. However, you as a requirements engineer cannot limit the stakeholders to provide their perspective, because different stakeholders will provide different inputs, and a useful requirements model can be generated as a result of the discussions that take place within the stakeholders, obviously with the help of the requirements engineers. The third type of inputs are the organization standards that are used within the customer or in the development organization. These may have to do with the software development standards, or they may also have to do with the business area that is being under consideration. For example, if one is developing software in healthcare industry and the clients are outside the country, then they may have to follow certain standards followed by those healthcare companies in their own countries. Those standards may not be applicable in the development company's country, but they may be applied in the client's country. So one needs to be familiar with these standards, and also there are software development standards, there are information technology standards, and there are other standards which are imposed by different professional organizations. We have seen the concept of the healthcare, we have seen the concept of standards in healthcare industry. There are other safety and software development standards which are now becoming part of the software industry. For example, the CMM is becoming a standard which obviously has nothing to do with the application area, but it has something to do with how software is developed. And many companies require their developers to develop software using one of these standards. And on the other side, many companies say that we develop software using these standards. As a result, our processes are more refined and our development costs may be a little higher, but in the end the products may be of higher quality. So all of these things then limit the choices available in development of the requirements model. Regulations is also becoming a very important part of the input as far as requirements engineering processes are concerned. There are health and safety regulations for working, and there are health and safety regulations with respect to certain application domains and with respect to certain products. So regulations imposed by the government in use of software or in use of hardware is an important input in the development of requirements model, because it in certain cases limits the choices available to the development team in different aspects of the work. And lastly, another very important input of the requirements engineering process is the domain information. We had a very lengthy discussion on domain requirements previously, so we'll not go into that in much detail, but if domain information is not captured properly, the result will always be a product which is not going to be which is not going to satisfy the needs of the customers who are paying for this software product. So the advice given to the requirements engineers and the development team is to learn about the application domains that they are working on. This also enables them to specialize in those domains so that they can easily then win projects within that application domain, and their level of expertise will increase as much as they know if they do more projects in that same domain. So domain information is, I would say, holds the key to success or failure of a software project. If enough domain information has been gathered and understood, then there are chances of developing a product which the customer will like. And if not enough attention is given to this very important area, then the likelihood of dissatisfaction on the part of the customer is very high. Let's consider now the outputs that are produced by the requirements engineering process. The first and the most important output of the requirements engineering process is the agreed set of requirements. The agreed set of requirements describe the system so that the stakeholders can understand these. And these are basically the requirements stated in natural language so that not only the stakeholders can understand it, but also the system developers can understand it, and everyone can have the same level of understanding as far as the requirements are concerned. This is important because if requirements are ambiguous or inconsistent or incomplete, then there is a possibility then that a software product would be created that does not meet the stated goals of the customer. The second set of output is the system specification. This is a more detailed specification of the new system, and it may not be produced in all cases. In some cases, you would want to have a detailed description of what the system would like, and in simple products it is not necessary to produce system specification. The last output for the requirements engineering model are the system models. These are models based on one of these popular approaches. It can be an object model, it can be a data flow model, it can be a process model. These describe the system from different perspectives and gives insights to designers and developers on how to develop the system. They themselves do not contain the information on how to develop the system, but they give guidelines and information to designers and developers on how to do that. And they are also very useful for checking the consistency and completeness and ambiguity of the requirements. And once these system models are developed, it is very easy to ensure that the basics of the software product have been captured here, and the designers can then use these models to start their design activity. And you know that the design activity is primarily focused on developing a solution for the software problem that is being considered. Another aspect of the requirements engineering process is that it varies from one organization to another organization. And not only different organizations, but it also varies within an organization. And that is the real strength of developing a process for conducting the requirements engineering activities. It is important that not all problems be addressed in the same way, because the nature of all problems are different. Unstructured processes rely heavily on the experience of people, and while systematic processes are based on application of some analysis methodology, but they still require human judgment. So there are a number of factors which we will see today which affect the variability in software processes, especially in requirements engineering processes. But it is not a drawback, but in fact a strength that requirements engineering processes vary with each project, and they vary with different companies. So let's consider what are the variability factors for software processes. Let's consider the variability factors. As you can see on the slide, there are 4 variability factors which affect the requirements engineering processes. Number 1, it's the technical maturity. Number 2, disciplinary involvement. Number 3, organizational culture. And number 4, application domain. Now consider each one of them in detail. Technical maturity involves the technologies and methods used for requirements engineering, and they vary from one organization to another. And they also vary in some cases if we are dealing with large organizations, that these technologies and methods vary in different parts of a large organization. The second variability factor is the disciplinary involvement. The types of engineering and managerial disciplines involved in requirements vary from one organization to another. So this says that if you have more disciplines involved, then obviously the requirements engineering process will be different as compared to an organization which has fewer disciplines involved. The third variability factor is the organizational culture. The culture of an organization has an important effect on all businesses and technical processes. And since requirements engineering is both business and a technical process, it is deeply affected by the organizational culture that prevails within that organization. The impact of culture of an organization on requirements engineering is itself a research topic, and unfortunately we cannot go into much detail about it here, but we will address this in another lecture and see different aspects of the impact of organization culture on requirements engineering. The fourth and the last variability factor is the application domain itself. Some application domains are very difficult, are complex compared to others. For example, irrigation engineering is a complex domain. Compare that to a library information system, for example. If one is developing software models for the engineering projects like irrigation engineering, it involves a lot of mathematical and mechanical and physics which are not really part of the library information system, which is basically a simple information system and can be learned easily. On the other hand, if one is dealing with irrigation engineering, one has to learn about the different aspects, and a lot of engineering and physics, concepts of physics are included in that. And application domains bring lot of variability in how requirements engineering processes are executed. Requirements engineering process should be as rigorous as possible. Relatively simple domains do not require that kind of rigor in their processes as the complex domains would require. So recapping that these 4 variability factors are: number 1, technical maturity of the organization; disciplinary involvement from engineering and managerial perspective; organizational culture; application domain. And these impact the requirements engineering processes in ways which make it very different from all other processes. Now, even if the same company is developing software, these 4 factors will have major impact. For example, the change in application domain will be a very important factor in deciding which type of process should be used. And organizational culture will have almost no effect, because if the same company is developing software, then the organizational culture will remain the same. तो अगर एक ही कंपनी सॉफ्टवेयर बना रही है तो उसके रिक्वायरमेंट्स इंजीनियरिंग के प्रोसेसेस होंगे, उसमें टेक्निकल मैच्योरिटी, डिसिप्लिनरी इन्वॉल्वमेंट اور آرگنائزیشنل کلچر کا اتنا امپیکٹ نہیں ہوگا، لیکن اپلیکیشن ڈومین کا بہت زیادہ امپیکٹ ہو سکتا ہے. کہ اگر مثال کے طور پر جیسے پہلے کنسیڈر کیا ہے کہ اگر ایک کمپنی کی ایک ڈویژن اریگیشن انجینئرنگ کا کوئی پروجیکٹ کر رہی ہے اور دوسری جو ڈویژن ہے وہ MIS سے ریلیٹڈ کوئی پروجیکٹ کر رہی ہے، تو اس میں ٹیکنیکل میچورٹی اور ڈسپلنری انوالومنٹ ہے وہ اور آرگنائزیشنل کلچر کا بہت منیمل امپیکٹ ہوگا، لیکن اپلیکیشن ڈومینس کا ایک سگنیفیکنٹ امپیکٹ ہوگا. اور ریکوائرمنٹس انجینئرنگ کا جو پروسیس ہے وہ صرف اس ایک فیکٹر کی وجہ سے بہت زیادہ بدل سکتا ہے. اور بڑا آبویس ہے کہ ایک انفارمیشن سسٹم کا پروجیکٹ جو ہے وہ اتنی ریگولر ریکوائر نہیں کرتا جتنا ایک اریگیشن انجینئرنگ کا پروجیکٹ ریکوائر کرے گا، یا فار دیٹ میٹر ایک کنٹرول سافٹ ویئر بنانے والا پروجیکٹ جو کسی ہوائی جہاز کے کنٹرول سافٹ ویئر کا جو پروجیکٹ ہے اس کے اندر جو ریگر ہونی چاہیے وہ ایک MIS کے پروجیکٹ کے اندر ریگر نہیں ہو سکتی. اور یہ سب سافٹ ویئر انجینئرس کو اور سب مینیجرس کو بات بڑی آسانی سے سمجھ آتی ہے اور سمجھ آ سکتی ہے. لیٹس کنسیڈر واٹ آر دی ڈفرنٹ ایسپیکٹس آف ریکوائرمنٹس انجینئرنگ پروسیس. A requirements engineering process begins when there is a recognition that a problem exists and requires a solution. اور دوسری صورت یہ ہوتی ہے کہ ایک سافٹ ویئر کے بارے میں ایک نیا آئیڈیا جنریٹ ہوتا ہے. تو یہ دو صورتیں ہیں. پہلی صورت یہ ہے کہ ہمارے ایگزسٹنگ سافٹ ویئر میں کوئی پرابلم آتی ہے یا ایگزسٹنگ مینول سسٹم میں بھی کوئی پرابلم آتی ہے جس کا ہمیں سلوشن چاہیے ہوتا ہے. تو ریکوائرمنٹ انجینئرنگ پروسیس کو سٹارٹ کرنے کے لیے دو ہی پاسبلٹیز ہیں. پہلی یہ کہ ایک ریکگنیشن یہ ہو کہ کوئی پرابلم ہے اور اس کا ایک سلوشن چاہیے، اور دوسری صورت یہ ہے کہ اے نیو سافٹ ویئر آئیڈیا ارائزز. اور ریکوائرمنٹ انجینئرنگ پروسیس اینڈ کس وقت ہوتا ہے؟ اٹ اینڈز ود اے کمپلیٹ ڈسکرپشن آف دی ایکسٹرنل بیہیویئر آف دا سافٹ ویئر ٹو بی بلٹ. اس کے اوپر ہم کافی ڈسکشن کر چکے ہیں کہ ایکسٹرنل بیہیویئر کیا ہوتا ہے اور کمپلیٹ ڈسکرپشن سے ہماری کیا مراد ہے. جب ہم نے ریکوائرمنٹس کے اوپر ڈسکشن کی تھی تو ان دونوں ٹاپکس کے اوپر ہم سیر حاصل گفتگو کر چکے ہیں اور اب اس کو دہرانے کی یہاں پر ضرورت نہیں ہے. ریکوائرمنٹس انجینئرنگ پروسیس از اے کنٹینیوس پروسیس in which related activities are repeated until requirements are of acceptable quality. تو جیسے کہ یہ پہلے بھی بات گزر چکی ہے کہ ریکوائرمنٹس انجینئرنگ از ناٹ اے ون ٹائم کائنڈ آف پروسیس کہ آپ نے ایک ایکٹیویٹیز کو ایک دفعہ کنڈکٹ کر لیا اور وہ کافی ہے. نہیں، ریکوائرمنٹس انجینئرنگ کی جو ایکٹیویٹیز ہیں ان کو آپ کو بار بار دہرانا پڑتا ہے یہاں تک کہ ریکوائرمنٹس کی جو کوالٹی ہے وہ ایسی ہو کہ جس سے آپ کا کسٹمر بھی سیٹسفائیڈ ہو اور جس سے ریکوائرمنٹس انجینئر بھی سیٹسفائیڈ ہو کہ وی کین یوز دس سیٹ آف ریکوائرمنٹس ٹو ڈیولپ اے گڈ کوالٹی سافٹ ویئر. تو یہ نہیں سمجھنا چاہیے کہ ایک دفعہ آپ کسٹمر کے پاس گئے، اس سے ریکوائرمنٹس ڈسکس کیں، ان کو ڈاکومنٹ کیا اور ڈیزائنرس کو دے دیا کہ جی آپ جا کے اس کو ڈیزائن بنائیں اور ڈیولپ کریں. ایسے ہوگا تو آپ کی جو پروڈکٹ ہوگی وہ دیٹ ول نیور میٹ دی کسٹمرز نیڈس. So requirements engineering process is a continuous process. It requires you to go back to the customer to elicit the requirements again, to perform an analysis again, and to perform the negotiation again and document them again. And during this process you will realize that there are different problems with the requirements, that there are inconsistencies within the requirements, and that there are incompleteness that has emerged as a result of your knowledge of the domain. And then you would go to the customer and say, okay, this is the problem, we need to analyze this further, we need to negotiate it further, and there are inconsistencies that need to be resolved. So requirements engineering processes is a critical process which requires lot of effort on part of the requirements engineering team, but also the stakeholders, because stakeholders have to work together to come up with a consistent set of requirements model which can then be used for the development of the software product. So, and these requirements, along with the particular application domain and variability factors that we have talked about, would result in the tailoring of the requirements engineering process for that particular project. So requirements engineering process is a very critical process in the for the success of the software project or the development of a high quality software. Due care and importance and resources should be allocated for the execution of this process, and once this is done, then you can say that the foundation for the successful execution of the rest of the software lifecycle has been laid. Now let's consider what are the steps in the software requirements engineering process. Fundamentally, there are two main tasks of requirements engineering. Number one, it's the problem analysis, and number two, it's the product description. Problem analysis deals with the analysis associated with the problem that has resulted in the start of a software project, and the description is a complete specification of the desired system's external behavior. It consists of functional description, function requirements, or specifications, and we will see now what these are in more detail. The problem analysis consists of brainstorming. It consists of interviewing and eliciting requirements from the customers, from people who have knowledge about the domain, from the documents that exist in the current system, and it also involves documentation of all the possible constraints that will be applicable to the new software product. This, you can say, is an expansion of information. This is an expansion of information. You start off with possibly one page of the which says that they gives you an overview of what the new software will do, and when you conduct problem analysis, you will face with lots and lots of information and lots of data, which then must be categorized and classified into a consistent and complete set of requirements with the help of all stakeholders for that project. Problem analysis also deals with the trading off activity or the negotiation that is involved in dealing with constraints and organization of the information. You see, one of the most important and most difficult parts of dealing with information is organizing information. And if information is not organized, it will not be accessible to the concerned people, and if it is not accessible to the concerned people, then it cannot be of any use for the designers and developers. So organization of information is also part of the problem analysis, and as a result of the problem analysis, complete understanding should be achieved about what this software project is going to do and all different aspects of the software product. The product description, which is the second main task of requirements engineering, allows us to make decisions to define the external behavior of the software product. This is the functionality that we have talked about on what the software product looks like to its user. Product description also include organization of ideas, resolution of conflicting views, and elimination of inconsistencies and ambiguities from the requirements model. As the name suggests, that the activities involved in this task of requirements engineering is the functionalities of the product. It is product description. It gives you an overview of what the product would look like. when it's finally developed. We had said that these are the two main tasks, but one thing that should be highlighted here is that these two steps are not sequential. These two steps run in parallel and they run iteratively. You cannot say that I have completed my problem analysis and now I'm going to do my product description. These two things are not sequential. They are iteratively. You will do little problem analysis and then some product description, which will then followed by some more problem analysis and some more product description and so forth. So these are not sequential activities. These are iterative activities, and that point needs to be highlighted and understood well by all parties, not only the customers, but requirements engineers, as well as the current addressees who are the students of the requirements engineering course, that since some of you may be new to this profession and have not had the experience of working as a requirements engineer, should understand that there is no such thing as sequential execution of the requirements engineering process. It is a highly iterative task and it requires continuous involvement of the customer and continuous discussion with the customer to gather the necessary requirements and then to perform the analysis and negotiation activities and other activities in the requirements engineering process. We have seen this slide before in a different lecture when we were talking about coarse grain activity model, which described the context of the requirements engineering activities. Now let's talk about these activities in some detail. Requirements elicitation deals with gathering of requirements from different stakeholders. Requirements analysis and negotiation means that you have to analyze the gathered requirements and then you have to negotiate them with different stakeholders. Then there's this step of requirements specification and then this step of requirements validation. Let's take each one of them in more detail. Requirements elicitation is, as I've said, is the gathering of system requirements through consultation with stakeholders, from documents, from domain knowledge, and from market studies. We will talk about requirements elicitation in detail in actually more than one lectures during the semester, but it is sufficient to say here that without requirements elicitation, one cannot know what system to build. And so this is a very important and I would say the most important part of the requirements engineering process, in which the requirements engineers sit down with the stakeholders and try to understand the needs of the new software product. But that is not sufficient. They must also read different documents. They must also analyze the application domain, and they must also look at different market studies. They may have to also study competitor products in cases where it is applicable. Because of the internet, it has become very easy to share information, and one very important source for looking at system documents and domain knowledge and different market studies is to search the web such that they can gather different knowledge sources from the internet. This phase or this set of activities can also be named as requirements acquisition, or some people call it requirements discovery. Requirements elicitation is probably the most important activity in the requirements engineering processes. The second activity that we are seeing on the slide right now is the requirements analysis and negotiation activities. This again is a topic for an entire lecture, but we will briefly introduce this here. It involves understanding the relationships among various customer requirements and shaping those relationships to achieve a successful result. The successful result in our case would be an agreed set of requirements which can then be specified, and on the basis of that, system models can be developed. Negotiation among different stakeholders and requirements engineers is a difficult task. It is difficult because every stakeholder has his or her own view about the product that is being developed, and in fact that may not be the actual requirement that should be implemented in the software product. So requirements engineers have to learn this negotiation skill and inform the relevant customers and stakeholders that their differences are going to result in a product which will not be satisfactory for any one of these customers. Is a very important skill that the requirements engineers must learn. Requirements engineers may have to negotiate on the basis of the budgetary constraints that sometimes are put by the customers on certain requirements. Let's say a requirement is included in the requirements model which is very expensive to implement, but the customer is not willing to pay that much money for it. So some analysis and negotiation may have to be conducted in that case, keeping in view the budgetary constraints. The third activity that we will consider are the requirement specification. In this, a tangible model of requirements is built using natural language and some other specification languages. Building such a representation of requirements can allow us to assess these requirements for correctness, completeness, and consistency. These three characteristics have been our main characteristics as far as the requirements model are concerned, that the requirements model should be correct as much as possible, should be complete, and should not be inconsistent. So requirements specification activities will enable us to develop a tangible model of requirements using natural languages as well as diagrams and other specification languages, which will then can be assessed for these three fundamentally important characteristics, that is the correctness, completeness, and consistency. You can also see on your slide that a requirements document is produced as a result of the requirement specification. It contains detailed descriptions of the required software system in form of requirements captured in the requirements document. Software engineers, developers, and testers are the primary users of the requirements document. After the completion of the requirements phase, the requirements document becomes the contract between the requirements engineers and the software developers. It also then serves as sort of the technical contract between the customer and the developer team. The fourth main activity that you see on your slide is the requirements validation activity. Again, this is a topic for an entire lecture, but introducing it here, I would say that the review of the requirements model for consistency and completeness are included in the requirements validation activities. This process, which is the requirements validation process, is intended to detect problems in the requirements document before they are used as a basis for the system development. So in other words, we can say that the contract that I was talking about between the requirements team and the developers is validated in this step, and if there are any problems, those are removed before this document is given to the developers. The activities that we have seen in the requirements engineering slide that you have just seen there are 4 basic activities. One needs to have management activity that controls these 4 activities, and we can say that activity as a requirements management activity, although it's not shown here, but we will talk about requirements management in detail in a separate lecture when we get to that point. At this point, I would just like to recap the requirements engineering process. We have talked about requirements engineering process. We have looked at the high-level activities involved in the requirements engineering process, and we will talk about each of these activities in the lectures throughout the semester, and I hope that this introduction will enable you to understand these activities in much more detail when we take up these topics separately. Till then, Khuda Hafiz, and we'll meet you again next time. Thank you much.